Hey everybody, Trey here. Welcome back to another video. What started as a conditional severe risk turned into a full-fledged tornado outbreak yesterday across parts of the Midwest, in particular parts of Indiana and Ohio, where multiple discrete supercells developed and produced tornadoes, many of which may be rated as significant. And this was really not expected to occur. We did expect a severe weather threat up there that could materialize yesterday afternoon and evening, but did not really see this intense of tornadic activity on the bingo card for yesterday. So very impressive footage and photos have come out of these regions here. You see this tornado here was one of the main ones near Wapakoneta and Freiburg, Ohio. You can see how quickly this tornado develops, and just you can tell from the motion you see in the vortex there that this was a strong tornado. Some horizontal vortex action developed at times as well, and that's usually reserved for significant tornadoes. We've seen that in events like the April 27, 2011 super outbreak, and some of those EF4s and EF5s there, and many others as well. So very intense tornado that did quite a bit of damage across this area. Here's another shot of this tornado near Wapakoneta, Ohio. Very large tornado there. And there were also several other supercells that produced tornadoes, perhaps significant tornadoes. This was one near Winchester, Indiana, last night. Very impressive shot here from storm chaser Simon Brewer. And unfortunately, a lot of these tornadoes did a lot of damage, some pretty intense damage here. This was a mobile home park near Lakeview, Ohio that took a direct hit, and unfortunately these were killer tornadoes yesterday evening. So very sad to see that these tornadoes impacted people's lives and property, and hopefully in this video we can try to decipher some of the reasons why this setup overperformed in this area. Again, there was a severe threat yesterday morning across this area, a conditional threat for all hazards, but that quickly turned into a full-fledged tornado outbreak with many significant tornado-producing discrete supercells yesterday afternoon and evening across Indiana and Ohio. So again, in this video, our job is to try to determine some of the reasons why this event may have overperformed in that area, and turn this event from a run-of-the-mill Midwest severe event to a damaging killer tornado outbreak. So without further ado, let's go ahead and get started. So here's what we saw yesterday in terms of storm reports, a very active event from the southern plains into the Midwest, almost 700 severe reports in total, and really large hail was the main threat across this region. You can see all the green dots and black triangles there. That is indicative of large and significant hail. The black triangles indicate hail reports of 2 inches in diameter or greater. You can see over 500 hail reports in all, with almost 100 significant severe weather reports. And this is an example of the large hail that people were seeing yesterday. These are some almost baseball to softball size hail that fell near Ada, Oklahoma, did some pretty bad damage in town. Very impressive photos there of the hail near Ada, Oklahoma, and that was really the main threat yesterday with these storms. You can see, though, that the tornado reports were really confined to that Indiana-Ohio corridor, and elsewhere saw a very significant lack of tornadic activity. We did see one additional tornado near Hot Springs, Arkansas, I believe, and a tornado report came out of the Frisco, Texas area, but again, most of the tornadic activity was up there in the Indiana-Ohio corridor. Now, before we dive into the meteorology of this event, I want to discuss some of the comments I've been receiving regarding the forecasting of this event. I have received so many comments saying that the SPC and the NWS did a very poor job forecasting this event, that the SPC should have upgraded to at least an enhanced risk across the Indiana-Ohio corridor before the event yesterday, and the fact that they didn't allowed people to be less prepared, and lives were lost as a result. And frankly, that is just blatantly untrue and incorrect. This is the morning outlook issued at 8 a.m. Central Daylight Time yesterday morning, well before the outbreak began. And you can clearly see that almost all of Indiana and Ohio were under some sort of severe weather risk yesterday morning. The slight risk extended up through much of Indiana into western and central Ohio, and a marginal risk extended across pretty much the remainder of the state of Ohio. So almost the entirety of Indiana and Ohio were under some sort of severe weather risk yesterday morning, well before the outbreak began, and there were all hazards severe probabilities associated with those risk areas. There was a 5% tornado risk that extended across much of Indiana into western Ohio, 2% extended farther to the east. We also had a damaging wind risk area outlined, as well as a large to very large hail risk. Significant hail area extended through central Indiana. The hail risk extended much farther to the east across central Ohio as well. So these areas that were impacted yesterday were clearly under a severe weather risk with associated all hazards probabilities yesterday morning, way before the outbreak began. So, and it doesn't matter what category the risk is or how the probability is associated with that risk for all severe hazards. If you are in a severe weather risk area, you need to be prepared. And now I'm not taking anything away from the fact that people lost lives and property in this event. And of course, that's very, very sad to hear, and we never want to see that happen. But the bottom line is that these areas that were impacted by this outbreak yesterday were under some sort of severe weather risk well before the event began yesterday morning. Even though, in hindsight, is 2020. Should the SPC have maybe upgraded to enhanced risk in the afternoon outlooks? Maybe. But the bottom line is that all of these areas impacted by the outbreak were under some sort of severe weather risk. And it's not the SPC's nor the NWS's job to make you prepared. They can, put out all the messaging that they want about these events. Folks in these areas, if you are in a severe weather risk, regardless of the category, regardless of the probabilities associated with that risk, you need to be prepared for severe weather. And clearly, there were severe weather risk areas outlined here across this region. And so the folks in these regions should have been prepared for severe weather with an all hazards threat, as probabilities for all severe hazards, including tornadoes, were outlined here across this area. And, it's kind of a lose-lose situation for forecasters. If an event overperforms, it is the forecaster's fault. If the event underperforms, the forecasters are seen as too trigger happy, which is unfair. The atmosphere is super, super complex. One subtle change to one specific variable can lead to a totally different outcome from what was initially forecast. And so we have to definitely keep that in mind, and certainly, in my opinion here, this was no fault of the SPC, the NWS. They did a great job at messaging here, and clearly, these areas were under a severe weather risk well before the event began, even though at this time it was conditional. We talked about that in our forecast video yesterday, how conditional this threat would be, but if storms developed, we could see an all-hazards threat and a conditional threat for a strong tornado, which was clearly outlined in the discussions as well, if you were to read through those as well. So, bottom line is that all of these areas were under some sort of severe weather risk with all hazards possible yesterday morning, and folks in these areas should have been prepared. And so, the SPC definitely not at fault in this scenario. And, should they have upgraded? Maybe. But these areas should have been prepared for severe weather well before the outbreak began. All right, with that out of the way, let's dive into some meteorology. So again, this video is going to focus on the Indiana-Ohio portion of the event where the strong tornadoes occurred. We're not going to really talk about the rest of the event. Again, lots of large hail reports, and it's not really all that difficult to see why. Here are a couple of RAP proximity soundings from McAllister, Oklahoma, so near the storms in Oklahoma that produced the significant hail. And this one is at 18Z, this one is at 21Z. Not much change among the two, but as you can see, large instability, deep moisture, 75 over 63 there at the surface. So pretty strong instability for explosive updrafts, and a supercell favorable shear, deep layer shear almost up to 50 knots there, but limited low-level shear. Not much curvature there in the low levels of the hodograph, very unidirectional profile there in the low levels. So that combination of strong instability and weak low-level shear is a pretty common combination for large hail. And same thing at 21Z, large instability, almost 2,100 joules per kilogram mixed layer K, probably more than that in quite a few spots yesterday. And same thing, limited low-level shear. You might be first tempted to call this a little bit of curvature in the hodograph, but look at the wind profile here. Very wonky wind profile there in the low levels. Not much actual backing of the winds in the lowest levels of the atmosphere. Not much strengthening in that low-level flow as well. The low-level jet did decrease in intensity as the day went on, which in turn decreased the low-level shear. So again, large instability and weak low-level shear. That's a classic combo for significant hail. So we'll start out at 500 millibars, as we always do. As we talked about in our video yesterday morning, we had this big old cutoff low and trough here across the Great Basin, desert southwest, but that really wasn't going to be in play with any of the severe weather risk area. It was this belt of stronger flow out ahead of the main trough that was really going to be going to make the environment favorable for an all hazards type of threat. And as we went through the day, we had this little lead shortwave that kind of developed, not really much as far as curvature goes, but you can see a little bit in the height contours here. Just a very weak shortwave. We started to see some ridging even build into the central and southern plains. A little bit of height rises across this region, which didn't really hinder the overall storm development. We had our surface features that helped out immensely in that regard. But over here in the Midwest, really we had this little lead shortwave and this belt of stronger flow associated with this shortwave. 60, 70, 80 knots of flow here across Indiana, Ohio, Illinois, that region. You could very well consider this a straight jet streak. If we were to break this up into our 4-quadrant model, you'll see that area of Indiana and Ohio was right within that left exit region of the straight jet streak, which is our favored corridor for rising motion in these straight jet streak type scenarios. Also had additional development back here across Missouri and Illinois. Nothing much happened there other than some large hail and damaging winds, but our tornadic activity certainly was within this left exit region of this straighter jet streak. So given that we had more subtle forcing aloft here with just this more just broad plume of west-southwesterly flow in this very subtle shortwave, any redevelopment within the afternoon hours was likely to be discrete for quite a while. So that was why things were a little bit conditional. We weren't sure if storms would develop behind the morning round. We'll talk about the morning round of storms here in just a bit. But any development in the afternoon would tend to be discrete and pose that all hazards risk. Heading down to the surface at 12Z here yesterday morning, and we see just this broad, nebulous kind of surface low here. Not really any tight surface low centers within this broad cyclonic flow at the surface. Cold front draped down through here, cold front / dry line kind of composite boundary draped down here through the southern plains up to the Midwest. That would pretty much stay the same throughout much of the day. We didn't have that strong trough ejecting into the plains, so we're not expecting robust cyclogenesis out here. We did have a little bit more of a surface low center up in here that started to develop through the day. You'll see that kind of as we move on through the progression, a little bit more closed contours up there across the Midwest and Great Lakes region. And so we did have maybe a slightly stronger surface low up there, but for the most part, just this broad cyclonic flow at the surface troughing, if you will, with that cold front / dry line stretching all the way up into the Midwest. So surface low right in here, warm front draped here across the southern Great Lakes vicinity up into northern Ohio, northern Pennsylvania, with that cold front / dry line draped down to the south, and that was our main initiating boundary in the southern mode. While up here we were mostly up in the warm sector and up along the warm front. That was where the main convective initiation was expected to take place up there in the Indiana-Ohio corridor. 850 millibar pattern, very much the same. We saw that broad cyclone there in the low levels continue to move off to the northeast. Would make sense that your strongest low-level flow was situated up in the Midwest area, as that's where your strongest flow aloft was. Stronger mid and upper level response leads to a stronger low-level response. So down here in the southern portion of the risk area, here in Oklahoma and Texas and Arkansas, the low-level jet was waning with time, but up here we maintained a fairly strong southwesterly low-level jet across Illinois, Indiana, and Ohio, 40 to 45 knots out here. Plenty of low-level flow to enlarge those low-level photographs and create an environment conditionally favorable for tornadic activity. And one interesting thing to note here as well, we talked about this on the March 13th event up in northern Kansas, and then our dry line play down into Oklahoma, where we had southwesterly low-level flow. We talked about that day as having a negative effect on the environment along the dry line, as that was going to shovel in very much drier air from the west across atop the moist layer east of the dry line, and that was going to perhaps thwart storm initiation east of the dry line, which was a major negating factor in that southern play on the 13th. Here we also have a very southwesterly to west southwesterly low-level jet, but notice the green contours here. That's your moisture. So notice where the 850 millibar flow is pulling from back here to the west, moist air. So it's even though we have a west-southwesterly low-level jet here, it is not as negative of an impact in this scenario because it's pulling in low-level moisture from areas to the west, whereas here in the southern Oklahoma case, or southern plains case from March 13th, you had drier air being shunted in from the west on that westerly to southwesterly 850 millibar flow. Taking a look at our raw surface data here at 12Z, 7 a.m. Central Daylight Time, and we start off the day with pretty meager moisture across this region. 40s into low 50s dew points from Illinois into Indiana and Ohio. That was expected to change as the surface low shifted off to the northeast slowly, and we had continued warm moist advection into this region. And you'll see that happen as we go through the loop here. But notice this little disturbance in the winds across Indiana into Illinois during the morning hours with these thunderstorm symbols here. That was associated with some morning convection, and that was part of the reason why this setup was a little bit on the conditional side. We weren't sure how this complex of storms in the morning and its associated outflow would progress throughout the afternoon and perhaps impact the environment later on. Here's our wide view of the radar starting at 8 a.m. Central Time. Pretty broad complex of convection from northern Ohio and Indiana into Illinois into eastern Missouri. pretty broad complex there, and that continued on through the morning into a pretty stout squall line. It would eventually weaken as we went as it reached the Ohio region, but we did have one singular supercell here on the tail end that kind of devolved into its own discrete supercell and became surface-based as it approached the Ohio River, produced some tornadoes as it crossed the Ohio River in that southeast Indiana, northern Kentucky corridor. Here's some pretty impressive footage of that tornado here from pretty close range as it crossed the river near Madison, Indiana. Very impressive footage here that you can see the surface flow around that tornado. The flow on the water getting sucked into that vortex there with little vortices there in the funnel. Very, very impressive footage of this tornado from this lone supercell, and this was not really expected. And again, we were unsure how this complex would react going through the morning and into the early afternoon, but this was a little bit unexpected that this lone supercell here on the tail end would become a tornado producer. But I think as we had continued warm, moist advection here, that storm became surface-based right on the tail end as that better moisture reached this area. You'll see on the surface map here as we go back. So here is where that tornadic supercell occurred, right there in southeast Indiana to northern Kentucky. Initially, we start off with a very cool, dry air mass, 52 over 48 there at Louisville, I believe, or just to the northeast of Louisville there. As we go on with time, you'll see very quickly we destabilize that atmosphere on the tail end, 70 over 59 right there in far southeast Indiana. So the environment was quickly destabilizing, whereas up north we had a little bit worse moisture, 70 over 50, 66 over 50, a little bit cooler temperatures up here for the bulk of the squall line, and that allowed it to dissipate. But down here we were warming and moistening pretty quickly, and so once that caught up with that supercell, it was able to produce tornadoes. Now again, we weren't sure how this convective complex would play out through the morning and its associated outflow. We were thinking that the outflow boundary from this convection could be a favored corridor for all hazards development later on in the afternoon. And as this convective complex went through, you'll see here as it goes through Indiana and Ohio, we see pretty quick recovery behind it. Temperatures really rise pretty quickly into the upper 60s, low 70s. But the outflow from the convection would be much farther to the south, it looks like. If we go back to our radar here, that complex well up here in Ohio, that supercell down here, so its outflow would probably be down here and perhaps continuing to push south through the morning and early afternoon hours. So the outflow boundary probably did not have a significant impact in the region of greatest tornadic activity up here in eastern Indiana to central Ohio. So that was, I think, one of the hypotheses that has been posited was the outflow from this morning convection, and I don't think it played as much of a role. You see here at 21Z, so 4 p.m. Central Daylight Time, we do have a little bit of a heating boundary down here, perhaps a little bit of a wind shift, more southwesterly winds over central Kentucky, slightly more backflow up here across northern Kentucky. So the outflow, we also have some heating. A little bit of a heating boundary here, differential heating boundary, 78 degrees at Louisville, 76 here to the east, with low 70s here to the north. So the outflow from this complex was probably somewhere in this vicinity here. So well to the south of our actual region of tornadic activity up here in east central Indiana to central Ohio. So I don't think the outflow played a role, but notice here a couple of things we do have going for us here as far as the wind profiles go. So you'll notice here into central Ohio, or west central Ohio, eastern Indiana, by 0Z, we do have a little bit of a differential heating boundary up in here as well. We had our outflow differential heating down here, but up here into Ohio, we also appeared to have a little bit of a heating boundary. It might be a little bit better defined just before the thunderstorms developed. But you see here in southwest Ohio near the Wilmington area, 75 degrees, 73 here in southeast Indiana, whereas we have temperatures in the upper 60s here. So it does look like we have a little bit of a differential heating boundary somewhere in this vicinity here. And it perhaps lifted a little bit north as we went into the early evening hours. You see here at 0Z, 71 over 61, 70 over 66, 66 degrees, 65 degrees up here to the north. So it does appear that there may have been a little bit of a differential heating boundary here, and that could have been a potential focus for storm development here. Again, I don't believe this is outflow from the morning convection, as that was relegated here to the south, but this may be a secondary differential heating boundary that developed and perhaps aided in increasing low-level shear along it and favoring storm development along that boundary. Also notice here at 0Z, we have a nice area of backed low-level winds here. Pretty much due southerly low-level winds, even south-southeasterly winds as we get toward the Columbus, Ohio area. If we look at our forecast models, they were showing a little bit different of a story. This is valid. This is the 12Z NAM from yesterday morning, so the morning run of the NAM on the day of the event. And this is valid at 7 p.m. Central Daylight Time, so as those tornadoes were ongoing across eastern Indiana into central Ohio. Take a look at the surface winds here, and I will zoom in on that Indiana-Ohio corridor. The surface winds are very much veered, very much southwesterly surface winds, and that would have a tendency to decrease the low-level shear in this environment. So the fact that we had a little bit more backed low-level winds was, I think, pretty key in this scenario across this region. Instead of having more southwesterly flow, especially here across west-central Ohio, we had a lot more southerly to south-southeasterly flow here, which would allow hodographs to enlarge and increase the low-level shear in this environment. Now, why did we get an area of backed flow in western Ohio? It's a little bit difficult to ascertain. It does look to me, though, that what the models were depicting as far as the geometry and orientation of the surface flow may have been a little bit different than what actually happened. Here is, again, that 12Z NAM run from yesterday morning, the morning of our event. And here's our surface flow up here in the southern Great Lakes region, these closed contours you see there in the pink circle. If we were to draw an axis through the center of this surface flow, it would be quite meridional, very west to east orientation of that kind of axis of the surface flow, if you will. And if we were to look at what actually happened using our mesoanalysis, this is at 23Z, and you'll see here the kind of axis of the surface flow a little bit more tilted, a little bit more upright, if you will, a little bit more north-south component to it. So that may have allowed the winds here to back a little bit of a surface trough extending out from to the southeast of the surface flow center. So that may have helped the surface winds back just enough here to create a little bit of enhanced low-level shear than what models were showing. By midday, 17Z here, so noon Central Daylight Time, those 60s dew points, we're starting to creep up into southern Illinois and Indiana there, continuing their trek northeastward. And as we went into the afternoon, they would make their way up into western Ohio with mid-50s dew points all the way into central portions of the state. This was another one of the differences between the models and what actually happened that could have added some more fuel to the environment than what was initially expected. This is the SPC HREF, so the High Resolution Ensemble Forecast System. Basically, it takes into account all of those convection allowing models that we look at, the HRR, the NAM NEST, the WRF ARW, NSSL WRF, all of those models, and basically treats them as an ensemble. So we can look at fields like moisture, instability, simulated reflectivity, and get averages or ensemble means of those products to see how the convection allowing models are acting as a whole instead of just looking at one particular model. So this was the 12Z suite of convection allowing guidance from yesterday morning. So the morning run of the CAMs. And this is what it was showing for the ensemble mean dew point. The blue colors are 60s dew points or greater, and the dark greens are dew point temperatures in the 50s. And you can see here that we only had 60s dew points, at least among all the CAM models, barely squeaking into southwest Ohio, into eastern Indiana, with more marginal moisture out to the east. And that was not exactly what happened. We had a little bit of an overperformance in the moisture. You can see here by 0Z, 7 p.m., we had some robust 60s dew points impinging upon even west central Ohio here, with much better moisture farther to the east for these supercells to act upon. So it looks like moisture was one of the overperforming variables in this setup. We had a little bit better moisture make its way farther to the east, and therefore we had a wider swath of potential real estate with which these supercells could work as far as a favorable air mass, at least from the surface moisture perspective. We'll look at a full sounding here in just a second to see the overall environment in this area, but it looks like surface moisture was a little bit better than anticipated farther to the east. We also had very rapid destabilization behind the morning convection. That was a little bit of a question mark early on in the forecast period, but it quickly became apparent that that was not going to be an issue. Here's our visible satellite imagery, and you see that complex moving through Illinois just before 9 a.m. Central Time. This big old complex of clouds here, that was our morning convection. Continued to move off to the east during the morning and weaken as it moved into Ohio, but notice right behind that convection, ample clearing right immediately behind that convection. Oftentimes we'll have a lot of lingering cloud cover back here, and that will help to thwart rapid destabilization behind the morning line. But here you can see very limited cloud cover behind that initial complex, and we're already starting to develop some bubbly cumulus out to the west over Missouri into western Illinois, and that would be our preferred area for storm initiation, at least initially with the afternoon wave before the convection would spread off to the east. And we had additional development, first convective attempts here across across central Illinois right after 2 p.m., and that would be our main wave moving into Indiana and Illinois. But really a very favorably destabilized environment behind the morning round. It quickly became apparent that we were going to have a fully recovered environment and set the stage really for multiple supercells across this area going into the afternoon. As mentioned, discrete supercells began to fire across first eastern Missouri and then in separate area across northern Indiana moving into Ohio, which is where our main round of tornadic activity came from. Those storms became pretty robust pretty quickly in a fairly semi-discrete mode. So with all that warm, moist advection moving up into the region and rapid destabilization behind the line, it was becoming pretty apparent pretty quickly that we were going to see that all hazards threat come to fruition. We still didn't really know the extent or the intensity of that tornado threat because really that area of backed flow did not develop all that quickly behind the morning round. We still see some veered winds out here across western Ohio and Indiana going into the mid-afternoon as those storms were firing. And then finally, going into the evening hours, we started to finally see that area of backed flow right along the Indiana-Ohio border out to the east, which those storms tracked right into. So it still was not super apparent that we were going to see a real intense tornado outbreak until very shortly before the event. But we did have a discrete storm mode. Destabilization behind the morning round was not a problem, and so we were able to get storms to fire pretty quickly. They became surface-based and moved into a very more and more favorable environment for significant tornadic supercells with time. Here's a bit of a closer view from the Wilmington, Ohio radar down there in southwest Ohio. Initially, discrete supercells really initially had a large hail threat, 3-body scatter spike right here from this storm, which would be the eventual Wapakoneta tornado producer as it was south of Fort Wayne. Went on to become tornadic there, bounded weak echo region here on the reflectivity. We are pretty far from the radar, so we are looking a little bit higher up in the storm, but nice bounded weak echo region there as that storm was getting its act together. Continued to move off to the east and would really start to get its act together as it approached the Wapakoneta area. And perhaps that had something to do with the storm interactions. You see here this storm on its western flank began to approach and almost attach to the southwestern flank of the storm. And at this point was when this lead supercell became pretty strongly tornadic, and that was that initial footage you saw from near Freiburg and Wapakoneta, Ohio. Here is the velocity data, and you'll see that as we go through the loop here. Velocities really start to ramp up as that storm approaches Wapakoneta area. You see minimal velocity, some velocity signature there with that lead supercell, but eventually it did start to really ramp up right as that storm began to almost attach to its southwest flank. So definitely some storm interactions were at play there in aiding in tornadogenesis. And then we continued to have tornadic supercells back to the west. That one that moved in from eastern Indiana near the Winchester area had a pretty nice tight couplet with it. Also had a bit of a bounded weak echo region. It's this storm back in here, initially producing some large hail, but then started to become tornadic pretty quickly as it approached eastern Indiana, Ohio border. Nice bounded weak echo region, kind of a donut hole there. Very textbook tornadic supercells here in this portion of the Midwest. Here's a close-up view of the initial Wapakoneta tornadic supercell as it moved closer to the Columbus metro area. This is from the Columbus Airport terminal Doppler radar, so we could get a very close-in view despite the lack of WSR-88D radars in this area. Again, textbook tornadic supercell, very wrapped-up hook echo there, and you can even see the boundaries here, the storm scale boundaries that were at play with this storm. Here's our tornado, very strong velocity signature there just south of Berkshire, very tight velocity couplet. The rear flank downdraft, very, very clear rear flank downdraft gust front in boundary right in there. The boundary between the inbound pixels, the greens, and the reds, the outbound pixels from the radar. Very tight boundary there on the RFD gust front, and our forward flank gust front right in there as well. And right at the interface of those two boundaries, very wrapped up tornadic circulation. And instead of using a RAP model proximity sounding as we always do, we have a pretty close observed sounding from the area that these tornadic supercells were ongoing. This is the Wilmington, Ohio observed sounding from 7 p.m. Central Daylight Time yesterday evening as those supercells were ongoing and producing tornadoes. And you can just look at this and see that this is a pretty textbook sounding for a significant tornadic supercell environment. First of all, deep low-level moisture. Not only was the surface moisture a little bit better than expected at farther east into Ohio, 71/60 there at the surface, but the moisture was extremely deep, very, very deep moisture, up to almost above 700 millibars there. So extremely deep moisture beneath a little bit of drier air aloft. That is a very positive sign for tornadic supercells. That means they have a lot more juice, a lot more fuel to work with there in the low to mid levels of the atmosphere. Very, very deep moisture, leading to strong instability. The fact that we had better moisture moving into the region and strong surface heating behind that initial round of storms in the morning allowed for pretty decent destabilization throughout the day. Mixed layer CAPE in excess of 1,200 joules per kilogram. Certainly nothing mind-blowing there by any means, but more than adequate to produce robust convection within a strongly sheared environment, and strongly sheared it was. Strong deep layer shear for supercells, very lengthy photographs, upwards of 65 knots of effective bulk shear, so strong deep layer shear for supercells, and as we talked about, given fairly subtle forcing in the background, the storms were going to be discrete, so just a discrete supercell mode for several hours was the favored mode given strong deep layer shear. And just look at that wind profile. A little bit more backed low-level flow than what was anticipated, almost due southerly winds here at Wilmington, which allowed for a nicely curved low-level photograph, strong effective storm relative helicity in excess of 400 meters squared per second squared. So with a fully destabilized environment, deep moisture, with very strong low-level and deep layer shear, this certainly was an environment that was favorable for significant tornadoes, although it was not what was portrayed initially among the models as far as the environment goes. Here is a NAM sounding from western Ohio, just north of the Dayton area, from yesterday's morning NAM run, valid at 7 p.m. yesterday evening. So you can see a pretty potent environment here as well, with decent instability, actually stronger instability than what was depicted on the observed sounding, 2,200 joules per kilogram mixed layer CAPE. You can see that the surface temperatures were much cooler, not quite as high of a surface dew point there on this NAM sounding, but still overall a fully destabilized environment. But our wind profile is a little bit wonky. We do see a strong effective storm relative helicity in excess of 300 meters squared per second squared, but we do see very little curvature in the low levels of the photograph. The pink area is going to be that 0 to 1 kilometer layer here, and you see very limited curvature in the low levels of the photograph. We had very ample speed shear in this layer, the change in wind speed with height. You see surface winds at 10 knots there, going up to about 50 knots at 1 kilometer, and speed shear is a component of shear. So when you have strong speed shear in the low levels, that can definitely induce tornadic activity. But we don't have a lot of directional shear, very unidirectional flow, very much just southwesterly flow there in the lowest kilometer of the atmosphere, leading to a very limited curvature there in the low levels of the photograph. So this was certainly an environment progged by the NAM that would favor an all-hazards threat, but potentially not really a significant all-hazards threat. We do have, just from a value standpoint, again, about 330 meters squared per second squared effective storm relative helicity, and what actually happened was about 100 meters squared per second squared SRH greater than that, and a much more curved low-level photograph. Look at the curvature there in the low-level 0 to 1 kilometer layer. A lot more directional shear, strong veering and strengthening of the winds with height on this particular observed sounding from Wilmington at the time of the ongoing tornadic supercells. And that was, again, a lot different from what models were showing. A much more backed low-level flow, more southerly low-level flow than what was anticipated, leading to much more directional and speed shear in the low levels, really consummating the overall significant tornado environment, which was before definitely favorable for tornadoes, but perhaps not significant tornadoes. Here, this is certainly a sounding in a fully destabilized environment that would support significant tornadoes with very strong, much stronger storm relative helicity than what was anticipated, and much stronger directional shear in the low levels than what was anticipated. Lots of streamwise vorticity as well. Didn't mention that earlier, but very strong streamwise vorticity. That's when your storm relative wind vector and your horizontal vorticity vector, which is perpendicular and to the left of the photograph, when those two vectors are parallel to each other, you have strong streamwise vorticity, which is much more favorable for tornadic supercells to use to become tornadic than crosswise vorticity, which would be when these vectors are more perpendicular. So very strong streamwise vorticity in the low levels of the atmosphere up to through that 0 to 1 kilometer layer. All in all, a very favorable environment for significant tornadic supercells that really, again, came together in only the couple of hours leading up to the event. Again, this is what we were dealing with in the morning. Certainly an environment favorable for tornadoes. Wind profile, though, not all that favorable for significant tornadoes, given very limited directional shear in the low levels, but much stronger directional shear than it was actually anticipated, given that much stronger veering of the low-level wind profile with height, given stronger backed winds at the surface. So all in all, things came together pretty quickly leading up to this event to make this a prime environment for significant tornadic supercells. You could also see a pretty stark difference between the storm relative helicity and low-level shear in the southern portions of the risk area versus areas to the northeast in the Midwest. Here's the SPC mesoanalysis effective storm relative helicity at 0Z, so 7 p.m. Central Daylight Time yesterday, and you can see not much SRH for these storms to work with across Texas, Oklahoma, and Arkansas, therefore not a lot of tornadic activity in these areas. Compare that to farther to the northeast, in areas like Indiana and Ohio. 7 p.m. we saw a drastic increase in low-level shear, 2 to 400 meters squared per second squared effective storm relative helicity. When you have discrete supercells in a fully destabilized environment with this much low-level shear, bad things are bound to happen. So the bottom line is that this was a setup, an environment that really came together very shortly before the event happened. Our morning models and the data leading up to the event just simply did not signify a significant tornado outbreak. Certainly a conditional all hazards threat, but we needed, number one, to get discrete supercells to fire, which we answered that question pretty quickly behind the morning round with all that destabilization very rapidly in the wake of that morning convection. But the overall profile for these storms to work with really only came together in the couple of hours leading up to the event. We had, again, better moisture return farther east into Ohio, much more real estate for those supercells to work with, much juicier air for those supercells to work with than what was anticipated, as well as much stronger low-level shear, particularly directional shear, with an area of much stronger backed winds in that western Ohio corridor that allowed for stronger low-level shear than what was anticipated, and definitely more veering with height, much more curved, clockwise curved photographs, more streamlined vorticity for those storms to work with. And all in all, that came together for a significant tornado outbreak there in eastern Indiana and Ohio. And again, it's nobody's fault. It's not SPC's fault. They had the risk areas out. They did mention that it was a possibility for an all hazards threat up there. But, sometimes, even the best forecasters in the world just are not, they have to use what they have at their disposal, the data and the model data that is coming in throughout the day, and that just was not showing a significant tornado event until just a couple hours before. So, this is definitely a great learning experience for all of us, in pattern recognition, especially going forward. If we see one of these types of events in the future, we'll know what to look for. But all in all, a very impressive event, one that will be definitely one of the more memorable ones this year, and that produced some pretty significant tornadoes. So that's going to do it for this video. Hopefully that gave you a little bit of insight into why things went how they went up there in the Indiana-Ohio corridor. And that's going to do it. So thanks for watching, and we'll see you in the next video.